Hello grade 9 students. Today I am here to teach you chapter 19 in your textbook, that's Pythagorean Relation. So this is an important relationship every day without knowing we are using. Constructing buildings, carpentry, in all situations without knowing we are using this relationship. We'll see what are the basics. Look at this triangle. What is this triangle? One angle is 90 degrees. What do you call that? Right angle triangle. So this is ABC right angle triangle. So what's the B angle? B angle is 90 degrees. Or you can write just B. B letter, that's 90 degrees. The side opposite to B angle. What's the side opposite to B angle is? AC. What do you call that? That's the longest side in a right angle triangle. Always opposite to 90 degrees is the longest side. So what do you call that? We call that it's the hypotenuse. So this is the hypotenuse. Now, how we find out the hypotenuse? We know in ABC triangle, B is the angle. So, we refer close B. What are the other two letters? AC. So, you can find out the hypotenuse by looking at this angle. You don't need a diagram. So, AC is the hypotenuse. When you close B letter from your vision, you can see the hypotenuse AC. Look at this triangle. B is 90 degrees and sides enclosing the right angle. So these are the two sides enclosing this angle. So this is the included angle to these sides. B angle is 90. So AB, BC are the sides enclosing the right angle. So how we take those two lines? AB and BC. So here B is the angle that's common. Can you see? B is common. That's the angle. And we take the other two letters. So AB and BC are the two sides enclosing the right angle. Look at this triangle PQR. Which angle is 90? P angle. Or you can write QPR angle is 90. So what's the hypotenuse? Close P, you get QR. So QR is the hypotenuse. The sides enclosing the right angle. So P is the angle. So P should be common. So P is there. So what are the other two letters? PR and PQ. So PQ and PR are the sides enclosing the right angle. Triangle ABC. Without drawing, can you identify? A angle is 90. So what's the hypotenuse? When you close this, hypotenuse is BC. What are the two sides enclosing the right angle? So A is the common one. So you get AA. So 1 with B. So AB and AC. XYZ triangle. Y angle is 90. So how you write down the hypotenuse? When you close Y, XZ is the hypotenuse. Sides enclosing the right angle. So Y is the angle. So that's common. And XY and YZ are the two sides. The sides enclosing the right angle are ABBC. Now other way around, two sides are given. So how you identify the 90-degree angle? That's the common letter. So B angle is 90 degrees. Hypotenuse. B angle 90 means we know that AC is the hypotenuse. KLM triangle. LK, LM are the sides enclosing the right angle. Which letter is common? L. L letter is common. That's the angle. So find the right angle. So L angle, or you can write KLM angle is the right angle. In the CDE triangle, E angle is 90 degrees. Write down the hypotenuse and the sides enclosing the right angle. How you write down the hypotenuse? That's CD. What are the sides? So E is common and we write with the other two letters, DE and CE. Those are the two sides enclosing the right angle. There's a diagram. Complete the following table. Triangle ABC. So this one. Now identify hypotenuse. Opposite to this, that's AC. The sides enclosing the right angle, BA and BC, or AB and BC. AC is the hypotenuse. ACE, take the other triangle. ACE. Now consider this triangle. So 90-degree angle is C angle. So what's the hypotenuse? AE. Then what are the two sides? AC and CE. CDE triangle. CDE triangle is this one. So CDE triangle, what's the hypotenuse? Opposite to 90 degrees, CE. So what are the two sides? CD and DE. Question number 9. By looking at the above diagram, complete the following table. RBS. This one. Hypotenuse is SR. What's the sides enclosing the right angle? BS and BR. Next one, SCP. SCP is this one. What's the hypotenuse? PS. So what are the two sides? CS and CP. PDQ. PDQ. This one. So what's the hypotenuse? Opposite to D angle. PQ. And what are the two sides? DQ and DP. AQR. This one. What's the hypotenuse? QR. And what are the two sides? AQ and AR. PQR triangle. PQR. This one. This triangle now. PQR. What's the hypotenuse? Opposite to 90. That's PR. And what are the two sides? QR and QP or PQ. And finally PRS. PRS. This one. What's the hypotenuse? Opposite to S. PR. And what are the two sides? SR and SP. Now you know how to identify the hypotenuse and the two sides enclosing the right angle. Look at these three squares. This is 3 centimeter length, 4 centimeters, 5 centimeters. So each square is 1 centimeter. What's the area of square A? Length into breadth. 3 times 3, you get 9 square centimeters. Area of square B, 4 times 4. 4 times 4, you get 16 square centimeters. What about area of square C? 5 times 5, 25 square centimeters. By placing the three squares as shown, the PQR right angle is obtained. So here, this one we found, this is 9. This is 16 and 25. So keep like this, making a right angle here. The area of the squares drawn on the hypotenuse of a right angle triangle is equal to the sum of the areas of the squares drawn on the remaining two sides. So we'll see 9 plus 16, you get 25. So that's true. So 25 is the sum of areas of the squares drawn on the remaining two sides, as this was found by the mathematician Pythagoras. For the first time, this is named as the Pythagoras Theorem. So Pythagoras says when you get a right angle triangle, the area enclosed in the hypotenuse is equal to the area, the sum of areas in the sum of areas when you add in the other two sides. So what's the side of this side? This one is 4. If the length is 4, the area, we write 4 times 4, that's 60. The length is 3 here. What's the area here? 3 times 3, 9. Here 5 squares are there. So it becomes 5 times 5. So here 9 means 3 squared. 16 means 4 squared. And 25 means 5 squared. So it says the area of the square drawn on the hypotenuse. So this is equal to the sum of the areas. These are the two areas you are getting when you draw the squares. Areas of the squares drawn on the remaining two sides. Now take this right angle ABC. B angle is 90 degrees. What is AB squared means? AB squared means AB length is B, you square it. AB squared is the area of the square on AB. So when you draw another square like this, you get B squared. AC squared, AC times AC, A times A. So when you draw it, you get another square there. BC squared is the area here, C into C. So apply Pythagoras theorem to the right angle. What can you say? A squared is equal to B squared plus C squared. So always look at this one. This is the longest side. That's hypotenuse squared is the same as the sum of square terms of the other two sides. Now if you want B squared, how can you find out B squared? If you know A and C, you can subtract. So A squared minus C squared becomes B squared. If you want C squared, how you make C squared as the subject? You can take C squared is A squared minus B squared. Now when you use letters, what is AC squared? AC squared is equal to AB squared plus BC squared. That's the Pythagoras theorem. Then if you want to find out AB squared, what you do? We take the hypotenuse squared minus other sides, BC squared. If you want BC squared, how can you find out? AC squared minus AB squared. So you need to know when two sides are given, how you can find out the other side by making the subject of the formula. Write the Pythagoras theorem for each of the following triangles. So what's x squared? X squared is the longest side. X squared is hypotenuse. So x squared is equal to y squared plus z squared. Then how can you find out y squared? X squared minus z squared. How you find z squared? X squared minus y squared. This triangle, first identify the hypotenuse opposite to this one. So P squared is the sum of the other square terms, Q squared plus R squared. Then if you want Q squared, you subtract from P squared the R squared value. R squared, if you want R squared, you take P squared and minus the square term of Q. This triangle, A squared is not the hypotenuse. So C squared minus B squared. B squared is C squared minus A squared. So what is C squared? The sum A squared plus B squared. So always identify the hypotenuse first. So what's the hypotenuse here? AC. So AC squared is AB squared plus BC squared. AB squared, this one is AC squared minus BC squared. If you want BC, that's AC squared minus AB squared. This one again, right angle triangle. So PQ squared. PQ is just a side attached to 90 degrees, not the hypotenuse. So how can you write PQ squared? QR squared minus PR squared. How you find QR? QR is the hypotenuse. That's the sum of PQ squared plus PR squared. PR squared, this side, that's equal to QR squared minus. So we need PR, QR squared minus PQ squared. Find the length of the unknown sides. Now you have given hypotenuse is A. Other two sides are 4 centimeters and 3 centimeters. Now apply the Pythagoras theorem. What is A squared? We can write 3 squared plus 4 squared. Then A squared, 3 squared is 9, 4 squared is 16. 9 plus 16, 25. So A squared is 25 means when you take the square root both sides, you can find out the A value. Square root of 25 is 5. So the length of A is 5 centimeters. This one, BC squared. You need this side. How can you write down BC squared? The hypotenuse is 5. So 5 squared minus 3 squared. 5 squared means 5 times 5, 25. 3 squared is 9. So what's the value? You get 16. BC squared 16 means when you take the square root, you can find out the BC value. So what's the square root of 16? 4. 4 times 4. So 4 centimeters is the BC length. This one. PQR. PQ is not the hypotenuse. So how you find this one? 5 squared minus 4 squared. So 25 minus 16, that's 9. When you take square root both sides, you get 3 centimeter for this value. So when you get the square root, you can get minus or plus, but we take only positive values for length. KLM triangle, KL. KL is the hypotenuse. So that square is equal to 3 squared plus 4 squared. 3 squared is 9, 4 squared 16, you get 25. When you take square root both sides, you can find KL, that's 5 centimeters. This triangle, ABC, C angle is 90. BC is not the hypotenuse. So how you find out that? 10 squared minus 6 squared. 10 squared is 100. 6 squared, 6 times 6, 36. When you subtract, what you get? 64. So when you take square root for both sides, you get BC, that's 8 centimeters. Look at this diagram. Find the length of AC. This length. So we have to take the big triangle ABC. So what's AC squared? AC squared is equal to, hypotenuse is 20. So 20 squared minus 12 squared. 20 into 20 is 400. What's 12 times 12? You need to know square terms. 144. Subtract. 256. So when you take square root both sides, you get the AC length. That's, what's the value? 256. So you get 6 there. So what are the two possibilities you can get? 4 times 4 or 6 times 6. 14 or 16. 225 for 15. So definitely this should be 16. So we'll multiply and see. 36, 9. So you get 256. So that's 16 centimeters. Now we need to find out second part. Find the length of DC. Now can you see this length is equal to this length, but we found AC is 16. So 16 equally divide. So what's the DC value? 16 divided by 2, that's 8 centimeters. So this is 8. Now the third part, it says find the length of DE, this side. So you can take CDE triangle. In that triangle, apply Pythagoras theorem. DE squared is equal to, that's hypotenuse, 8 squared plus 6 squared. 64 and 36 you get 100 when you take square root of 100. You get 10 centimeters for DE. Look at this triangle. Two triangles and a rectangle. Find ABC, unknown lengths, and find the area of the trapezium. Look at ADP triangle. Here, A is the unknown length. So what is AP squared or A squared? That's not the hypotenuse. So you can take 25 squared minus 7 squared. 25 times 25, 625. 7 times 7, 49. When you subtract, what you get? 576. So what's the square root of 576? So the last digit is 6. So it can be 6 or 4. So 5 is there. So 24 or 26. What do you think? 25 times 25? That's 625. So less than 25. So this should be 24. So we'll multiply and see. 24 times 24. 675. 576. So that's 24 centimeters. That's AP. Now this is a rectangle, 90 degrees each angle. So this is a rectangle. So A and B should be the same. So what's B? B is same as A. That's 24 centimeters. And C? Yes, C also same thing. It's given. So C also 24 centimeters. That's the first part. Second part, find the area. How you find the area of the trapezium? What's the area? You can find separately area of the triangle. One triangle multiplied by 2 plus area of the rectangle. Or there's a formula for trapezium. So what's the formula? Length of the parallel lines, addition and multiplied by the perpendicular height divided by 2. So we'll use area of the triangle multiplied by 2. Area of the triangle half times base 7. Height is 24. That's one triangle multiplied by 2. and plus the area of the rectangle, 12 times A. So 12 times 24. What's the answer? 2 get cancelled out. 7 times 24 and 12 times 24. So 24 is common. Take it out. You get 7 plus 12. So 24 times 19. We'll multiply and see. 24 times 19. 10 and 9. 9 times 4, 36. 3 remaining. 9 times 2, 18. 18 plus 3, 21. 6, 5, 4. 456. So 456 square centimeters is the area of this trapezium. Look at this diagram. Find the length of OP. This length, find the area of the triangle ABO. Not C. ABO. ABO triangle. So how you find out the length of OP? So this length. Here this is 10 and this is 8. So you can straight away find out OP using Pythagoras theorem. OP squared is equal to 10 squared minus 8 squared because 10 is the hypotenuse. So 10 squared is 100 minus 64, you get 36. When you take the square root, you get the OP value. Square root of 36 is 6. So OP is 6 centimeters. Now we found out this is 6. So what's the area? Area of the triangle ABO. Area of ABO triangle is equal to half times base. Base is 8 and 8, 16. And the perpendicular height is the one we found, that's 6 centimeters. So 2 times 3, 16 times 3. 48 square centimeters. That's the area of the triangle ABO. Find the length of AQ. We can take this triangle ABQ. ABQ triangle. So find the length of AQ. So AQ squared is equal to 16 squared plus 12 squared because AQ is the hypotenuse. 16 squared, 16 times 16. What's the value? 256. 12 times 12, 144. When you add it, you get 400. So square root of 400 is 20. So 20 centimeters for the length AQ. Now AC. We'll take it in the other slide. Find AC. Now AC is this one. Look at carefully whether it's correct. AC, this is 16 and 12 and 12, 24. So 24 and 16 now. So what is AC squared? 16 squared plus 24 squared. 16 times 16, 256 we found before. 24 times 24. What's the value? 576. So when you add it, (832). What's the square root of 832? In the previous part, it's given. Take square root 832 is 28.8. So the answer is 28.8 centimeters. Now the next one. Which one? Find the length of PQ. So you have to take the PQB triangle. This is 12 and 8. So 12 and 8, we'll find out PQ length. PQ squared is equal to 8 squared plus 12 squared, because PQ is the hypotenuse. 8 times 8, 64. 12 times 12, 144. When you add it, you get 208. So what's PQ? Square root of 208. And the question says square root of 208 is 14.4. 14.4 centimeters for PQ. Now we'll look at example number 1 in your textbook. In the right angle triangle PQR, PQ is 8 centimeters, QR is 6. Find the length of PR. This is a right angle triangle. You can use Pythagoras Theorem. So what's PR squared? PQ squared plus QR squared. 8 squared plus 6 squared. 8 times 8, 64. 6 times 6, 36. When you add, you get 100. Take the square root both sides to get PR. So PR is 10 centimeters. Exercise 19.1. Write the Pythagorean relation for each right angle triangle using the given lengths. Hypotenuse is P. So P squared is equal to sum of square terms of the other two sides. A squared plus R squared. This one, what's the hypotenuse? X. So X squared is equal to Y squared plus Z squared. This one, hypotenuse is 10. So 10 squared is equal to 8 squared plus 6 squared. The other one, hypotenuse is Y. Y squared is equal to X squared plus 3 squared. Look at question number 2. Fill in the blanks in the expressions related to the figures shown below. AC squared, that's the hypotenuse. AB squared plus BC squared. This one, PR squared is equal to PQ squared and QR squared. This one, AD squared. Where's AD? This one. So this is the hypotenuse of this triangle, AOD triangle. So what is AD squared? AO squared plus OD squared. We'll take the other one, BO squared. BO, where's BO? This length. So we'll take this triangle now. So BO squared plus OA squared or AO squared is equal to AB squared. Now take the next one. BO squared plus OC squared. Now this triangle. This is 90 degrees. So what's that? BC squared. Then DC squared. DC squared is equal to OD squared plus OC squared. So when you get a right angle triangle, always find the hypotenuse and then decide whether it's add or subtraction. Identify all the right angle triangles in each diagram given below and write the Pythagorean relation for each triangle that is identified. We'll start with the big one. So big one we can take as XYZ triangle. So XYZ triangle, XC is the hypotenuse. So XC is equal to XY squared plus YZ squared. That's the big triangle. Then we can, so I'll highlight that one. Then you can take this triangle. What's that? PYZ. PYZ triangle. What can you say about that triangle? PZ is the hypotenuse. So PZ squared is equal to PY squared plus YZ squared. Now take another one. I'll take black. What's the other triangle? Here, this triangle. XYQ. XYQ triangle is a right angle triangle. This is 90. So XQ is the hypotenuse. XQ squared is equal to XY squared plus YQ squared. So that's from this triangle. So those are the three right angle triangles. This one. What are the right angle triangles? We'll start from here. This one. ADQ triangle. AQ is the hypotenuse. So AQ squared is AD squared plus DQ squared. Then we can take this triangle. So this triangle, this is 90 degrees. AQP triangle. AP is the hypotenuse. AP squared is equal to AQ squared plus PQ squared. Then you can take this small triangle. QCP triangle. So what's the hypotenuse? PQ. So PQ squared is equal to CQ squared and PC squared. Okay, look at this one. ABP triangle. So B is the 90-degree angle. So AP is the hypotenuse. So AP squared is equal to AB squared plus PB squared. So that's this one. And here we can take this triangle as well. ACB or ABC triangle. ABC triangle. AC is the hypotenuse. So AC squared is equal to AB squared plus BC squared. And we can take this triangle as well. This one is ACD. ACD triangle. You can write AC squared is equal to AD squared and CD squared. So we took all types of right angle triangles and found the relationship. Question number 4. Fill in the blanks in the statements given below which are related to the right angled triangle in the figure. The longest side of the triangle is the hypotenuse. What's the hypotenuse here? This is right angle triangle. So AC. By looking at the lengths also, 12 and 5. So 13 is AC. The area of the square drawn on the side AB is 12 times 12, 144. The area of the square drawn on the side BC, that's 5 times 5, 25 centimeters square. The area of the square drawn on side AC, so 13 is one's length. 13 times 13, 169 square centimeters. The sum of the areas of the squares drawn on the sides BC and BA. BC and BA, when you add, you get 144 plus 25. You get 169. Therefore, the areas of the square drawn on AC is equal, because this is also 169, equal to the sum of the areas of the squares drawn on BC and BA. Example number 2. A 5 meter long straight wooden rod is in a vertical plane with one end touching the top of a 4 meter high vertical wall. This is 4 meters. And the other end in contact with the horizontal ground a certain distance away from the foot of the wall. Find the horizontal distance from the foot of the wall to the point where the rod is in contact with the ground. So you are asked to find out this one, and this is 5 meter long rod. So this is a right angle triangle. So what's the hypotenuse? AC. So you can write straight away 5 squared is equal to 4 squared plus x squared. X squared is the BC length. 5 squared. So what is x squared here? You can take as subtraction. 5 squared minus 4 squared. So 5 squared is 25. 4 squared is 16. When you subtract, you get 9. So what's the square root of 9? That's 3. Square root of x squared is x. So x is 3 meters. Exercise 19.2. Find the length of each side indicated by an algebraic symbol in each figure. We need to find y. So we'll make y as the subject. Y squared is equal to 5 squared minus 4 squared, because we know hypotenuse is 5. 5 squared is 25. 4 squared 16. When you subtract, you get 9. So what's y? Square root of 9, that's 3 centimeters. This one, y is the hypotenuse, so you can write y squared is 9 squared plus 12 squared. 9 squared is 81. 12 times 12, 144. When you add it together, you get 225. What's the square root of 225? That's 15 centimeters. This one, again right angle triangle. So we need to find out m. So what's m squared? That's not the hypotenuse. So hypotenuse is 10. So 10 squared minus 8 squared. 10 squared is 100. 8 squared, 64. When you subtract, you get 36. Take the square root of 36. That's 6 centimeters. This one, we'll first find P to this triangle. P squared is 10 squared minus 8 squared, because 10 is the hypotenuse. 100 minus 64, that's 36. So P is square root of 36, that's 6 centimeters. Now find Q. We'll take the big triangle. So what's Q squared? That's the hypotenuse. 8 squared plus. Now what's the total length here? P is 6 and 9. 9 plus 6, 15. So 8 squared, 64. 15 squared, 15 times 15, 225. When you add it together, you get 289. Square root of 289. What should be the last digit to get 9? 3 times 3. Or 7 times 7. We know 225 for 15. So more than 15. Then 225 is 15. And this is 9 means 17 times 17. Check 17 times 17. You get what? 17 times 17? 289. So this is square root of 289 is 17 centimeters. Question number 2. Find the perimeter of each figure given below. So perimeter means we are taking only the outer length. So first we'll find out this one, that's same as these two lengths. So we'll find out AC. AC squared is, that's the hypotenuse for this triangle, ABC triangle. 6 squared plus 8 squared. 36 plus 64, you get 100. So take the square root, you get 10 centimeters for AC length. So this is 10 means this is also 10, this is also 10. Now we can find out the perimeter. Perimeter is the outer length. 6 plus 8 plus 10 and 10. So what's the total? 20, 28. 28 plus 6. You get 34 centimeters for the perimeter of this figure. This one, you need to find out the perimeter. So we need to find out this length. But first we need to find out PR. So what's PR is the hypotenuse for PQR triangle. So according to Pythagoras theorem, PR squared is 4 squared plus 3 squared. So 16 plus 9, you get 25. Square root of 25, you get 5 centimeters. So PR we found 5. Now you can apply Pythagoras theorem for PSR triangle. What is SR? SR is not the hypotenuse, so you have to take the subtraction. So that's equal to 13 squared minus 5 squared. 13 times 13, 169 minus 25. So you get 144. Take the square root. That's 12 centimeters. SR is 12. So what's the perimeter? Perimeter of this figure is 4, 3, and SR is 12 and 13. Add it together. 7, 9, 12, 1 remaining, so 3. 32 centimeters is the perimeter of this figure. This one. To find out the perimeter, you need this length. To find out this length, you need to find out this length first. So what is UV squared? 10 squared minus 6 squared when you take this triangle. So 100 minus 36 is 64. When you take the square root of 64, you get 8 centimeters. So that's this length. Now we'll apply Pythagoras again for UVT triangle. This triangle. So use Pythagoras theorem. UT squared is equal to 8 squared plus 15 squared. 8 squared is 64. 15 times 15, 225. So you get 289. What's the square root of 289? Square root of 289. So the last digit is 9. So you can get either 3 or 7. But we know square of 15 is 225. So if you take 13, it's less. So this should be 17. We'll check. 17 times 17. 7, 1, 49. 7 times 1, 7 plus 4, 11. So you get 289. So the square root value is 17. Now we found out UT. What's the perimeter of this figure? Perimeter. Perimeter of this figure is 10 plus UT is 17 plus 6 plus 15. 7 plus 6, 13. 13 plus 5, 18. 1 remaining. 2, 3, 4, 48 centimeters is the perimeter of this figure. This one. So you need to find out the perimeter. So we need this side, this length. But we'll find the whole length here and subtract this length. So when you apply Pythagoras theorem to DEC triangle, what can you say about EC squared? EC squared is 5 squared minus 4 squared. 25 minus 16, that's 9. So EC is square root 9. Square root 9 is 3. So we found this is 3. Now to big triangle ABC, you can use Pythagoras theorem. 13 squared is equal to, or you can straight away write down what we need. We need AC. So AC squared is equal to 13 squared minus 5 squared. 13 squared is 169 minus 25. So you get 144. When you take the square root, you get 12. So we'll find, I'll write down here AC is equal to square root of this, and AC equals 12. Now we found the whole thing is 12 and this is 3. So what is AE? AE becomes 12 minus 3, 9. Now we know AE. What's the perimeter of this figure? Perimeter is equal to, we'll start from here, 5 plus AE, that's 9, plus 4 plus 5 plus 13. So we started from here. So perimeter means length around the figure. Add it all together. 5 and 5, 10, 19, 23, 23 and 13, 36. 23 and 13 is 36 centimeters. So the perimeter is 36 centimeters. Question number 3. The diagonals BD and AC of the rhombus ABCD bisect each other perpendicularly at O. Moreover, BD equals 16. The whole length is 16 and this one is 12. So if this is 16, so this is 8 and 8 because equally divided. AC is 12, that means this is 6 and this is 6. Find the perimeter of the rhombus. So rhombus, all sides are equal. This side is equal to this side and here. So if you can find out one length, you can multiply by 4. So how you find out one length? We know this is a right angle triangle. We can use Pythagoras theorem. So we'll first find CD's length. CD squared is equal to 8 squared plus 6 squared. 64 plus 36, that's 100. So CD equals square root of 100, that's 10. 10 centimeters is the CD. Now you know one side is 10. So what's the perimeter? Perimeter is 4 times 10. You get 40 centimeters. Part 2. If the length of the diagonal AC of the square ABCD is 10. This is 10. Find the area of the square. We know in a square all sides are equal. So we'll put x here. Now to find out the area of the square we need x. X into x. But how can we find out x? We can see ABC is a right angle triangle. So you can use Pythagoras theorem. X squared plus x squared is equal to 10 squared. So 2x squared is equal to 100. X squared is 100 divided by 250 is x squared. What's the area? Area of the square is x into x, x squared. So x squared we found, that's 50. So the area of the square is 50 square centimeters. Part 3. In the circle with center O shown in the figure, the midpoint of the chord PQ is R. Moreover, OR produced meets the circle at S. ORP is 90 degrees. ORP PQ is 12. This is 12. So that means this is 6 and this one is 6. OR equals 8. So this small length is 8. Find the length of RQ. Okay, so straight away you can write RQ. RQ is half of PQ. So 12 divided by 2, that's 6 centimeters. Part 2, the radius of the circle. So radius is this, OP. Can you see this is a right angle triangle, OPR. OPR is a right angle triangle. So you can write OP squared is equal to 8 squared plus 6 squared, 64 plus 36, and you get 100. When you take the square root of 100, you get 10. So OP is 10. So that's the radius. So you can write radius is equal to 10 centimeters. Part 3, the length of RS. RS, this length. But we know OS is also radius. So OS is 10, but we know OR is 8. So what is RS? RS is 10 minus 8. So you get 2 centimeters for RS. Question number 4. In the triangle ABC, B angle is 90. AB is 8, BC is 6. The midpoints of BC and BA are R and P. Find the perimeter of the quadrilateral APRC. So we'll draw the diagram. Which angle is 90? B. So ABC. Triangle B is 90. AB 8. BC 6. The midpoints of BC and BA, R and P. So this is R, this is P. Find the perimeter of the quadrilateral APRC. APRC, this quadrilateral. So we need to find out the perimeter of this quadrilateral. So how we do that? We know the BC, the whole length is 6. So this is 3, this is 3 because this R is the midpoint. AB is 8. So this small part is 4, this is 4. We need to find out PR and AC. So we'll use Pythagoras theorem for PBR triangle. So we need PR. So PR is the hypotenuse. That square is equal to 4 squared plus 3 squared. So 16 plus 9, 25. Square root of 25, you get 5. So that's PR. Now apply Pythagoras for ABC triangle, the big one, 8 and 6. So when you apply that, we can write AC squared. Hypotenuse squared is 8 squared plus 6 squared. 64 plus 36, and you get 100. AC is square root of 100 is 10 centimeters. Now, what's the perimeter? Perimeter of APRC quadrilateral is, PR is 5, this length is 4, AC is 10 and RC 3. So when you add all together, what you get? 5 plus 4, 9. So 19, 22. So 22 centimeters is the perimeter of this figure. Miscellaneous exercise. Find the shortest distance between the points A, 4, 5, B, 10, 13 located on a Cartesian plane. So shortest distance is this distance, and here these two lengths are perpendicular. So how you can find? Now this is 10 and this is, here this y value is 13 and this y value is 5. So when you subtract, you get this distance. So 13 minus 5 here. This side, x value is 10, here 4. So 10 minus 4, this side. You know these two, so you can straight away find out the AB length. So 13 minus 5 is 8. 10 minus 4 is 6. So we can find AB squared is equal to, using Pythagoras, AB squared is equal to 8 squared plus 6 squared, 64 plus 36, that's 100, square root of 100. You get 10 centimeters for the shortest distance. So this is the shortest distance. Question number 2. The city Q is located 5 kilometers east of the city P. We'll try to draw the diagram. If P is here, east side means this way. So horizontally, the Q, not R, the Q point located 5 kilometers is the distance. And the city R is located 12 kilometers north of the city Q. North means straight away a vertical line. So R is 12 kilometers away from Q. Find the distance between the two cities P and R. We know east and north, this is 90-degree angle. So we can find out this distance. So PR squared is equal to 5 squared plus 12 squared using Pythagoras theorem. 25 plus 144, you get 169. So when you take the square root of 169, what you get? 13 kilometers. So that's the distance between cities P and R. Question number 3. To keep a 16-meter tall flag post vertical. 16-meter flag post vertical. One end of a supportive cable is attached to the top of the post, while the other end is fixed to a point on the ground horizontal 12 meters from the foot of the flag. So that means here 12 meters away from the foot of the flag post. Another cable is fixed. So this is one cable. Another cable is fixed from the opposite direction with one end attached to the flag post, 12 meters above its foot. So 12 meters above. So another cable is fixed from the opposite direction with one end attached to the flag post, 12 meters above its foot and the other to the ground. So this side. something like this. Other to the ground 9 meters from its foot. So this is 9 meters. Calculate the total length of the cable that has been used. So where's the cable? This is one cable and this is the other cable. So you need to find out the total length. So first we'll find out the length of this cable. I'll put letters A, B, C or something. And then this one PQ. So I need AB length and PQ. So we'll use Pythagoras to find out AB squared. Now we know this is 90 degrees. So we can use Pythagoras theorem. The whole thing is 16. So AB squared is 16 squared plus 12 squared. What's 16 times 16? 256. 12 times 12, 144. When you add it together, you get 400. So what's AB? Square root of 400, that's 20 meters. We found AB. Now we'll try to find out PQ. PQ squared, that's the hypotenuse for this triangle. PQ squared is equal to 12 squared plus 9 squared. 12 times 12, 144. 9 times 9, 81. So when you add it together, 225. So what's the square root of 225? That's 15. So we found that's 15. So what's the total length? So total length is equal to AB, that's 20, PQ is 15. So 35 meter cable. Look at this diagram. A tree which was struck by a tornado is shown in the figure. Find the height of the tree before it was struck. So that means we need to find out this length. So this plus this is the height of the tree. Now we know this is 90-degree angle. So we can use Pythagoras theorem. So I'll put A here. A squared is equal to 9 squared plus 12 squared. 81 plus 144. 5. So 225 means A equals square root of 225. That's 15 meters. So this is 15 and this is 9. The height of the tree. Height of the tree is 9 plus 15. So what's 9 plus 15? 24 meters. So the height of the tree is 24 meters. So we covered theory related to Pythagoras theorem. So in Pythagoras theorem, when you get a right angle triangle, the hypotenuse squared is equal to the sum of squares of the other two sides. So in this lesson, you need to know square terms. What are the square terms? 1 squared is 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225. So at least if you can remember up to this point, you can easily do the sums related to Pythagoras theorem.